Hi, my name's Dr. Peter Kay, and this is the next session on the heat transfer power and the environment module. And this series of videos are all about the environment. Okay, so this is what you should be able to do after the end of these sessions. So you should be able to discuss climate change issues. You should also understand the climate change policy, and I'm only going to look at that from a UK perspective. Should also be able to describe a range of technologies that are being developed to reduce the carbon dioxide concentration in the atmosphere through CCS, and also to discuss the potential renewable bioenergy sources that are being developed to help reduce the amount of carbon dioxide going into the atmosphere. Okay, so firstly, just going to give a brief introduction, and so what this pie chart here shows. So this shows the amount of where the CO2 or carbon dioxide is produced in the UK in 2015, and you can see on here that the biggest kind of culprits here is energy supply, perhaps unsurprisingly. So all the fuel that is consumed to generate electricity to keep our lights on, and which is about 30% of total carbon dioxide produced. And one of the other biggest single sources is or sectors is transportation, which is nearly a quarter. So that does include rail and freight, as well as domestic commuting and things like that. It should be pointed out here that all the numbers, and you can scan this QR code to go and look at the data yourself, are quoted in what's called megatons of carbon dioxide equivalent. And the reason for that is because obviously there's a carbon dioxide cost to everything, and depending on what your fuel source is, that can depending on what your fuel source is, the amount of carbon dioxide that's being produced might not be indicative. So it's kind of this sort of standard of megatons of carbon dioxide equivalent is used, and what that is actually equal to is that's the amount of carbon dioxide that would be released if you were to burn 1 ton of oil. So for comparison, regardless of what the fuel source is, it's all converted into this tons of CO2 equivalent, so you can make a direct comparison between different sectors and different technologies. Okay, so we know that we produce carbon dioxide in relatively large quantities, and it's widely regarded that this is the reason for the climate change which we're observing now. Some people disagree with this and think that man-made carbon dioxide isn't a source of climate change. And if you're in any doubt, then I'm going to present some evidence here that you'll hopefully agree with, and to show you that we believe it is man-made carbon dioxide that's causing climate change. So firstly, there's a thing which you've probably heard of, is the greenhouse effect. Okay, what this is basically this is a warming of the Earth. Okay, so what it is light from the sun strikes the Earth's atmosphere. Okay, here, and about 50% of it reaches the surface, and about 50%, and the remainder is either reflected or absorbed into the atmosphere. Okay. The remaining radiation that reaches the surface is absorbed by the Earth, and as it's absorbed, when it's radiated at a longer wavelength. That means that it's not, because it's radiated at longer wavelength, it's reabsorbed by gases in the atmosphere, particularly carbon dioxide. So most of the radiation that goes out is absorbed into the atmosphere, warming it, and consequently, as a result of that, the radiation that's been absorbed into the atmosphere is it is re-emitted, and admittedly in all directions, so some of it will, a proportion of it will go back out into space, but the majority of it is trapped within the atmosphere, and is emitted in all directions, including back towards the Earth's surface. So this effect is responsible for an increase in the surface temperature on Earth, and this can be proved. You can do this in a lab. You can this was done decades ago by scientists who proved that this is an effect. Even without studying the atmosphere, they could do it in the lab and show that if you have gases, they will trap, create this greenhouse effect. When you shine line through it and it's reabsorbed, etc., it increases the temperature. So some of the indicators of climate change are, so this shows the sea level rising with increasing time since the 1880s. You can see it's increased fairly dramatically. That correlates with the increase in temperature in the Earth's atmosphere, also the temperature on the Earth's surface. And that's obviously going up with time as well. And finally, both of these can be correlated to the concentration of carbon dioxide in the Earth's atmosphere. And you can see that's obviously going up in the same way over the same. That's going up with this with increase of carbon dioxide in the Earth's atmosphere as well. So you can see that all these appear to be linked, and we believe that they are, as they've all got the same trends. So some people say that the global temperature is slowing. Well, you can see by looking at this plot, it's clearly not. If you look back to the 1880s, no one would argue that the temperature is slowing. In fact, if you take the last year's data, it seems to be increasing rapidly. However, some people or skeptics have focused on the last decade's worth of data, and if you draw a line through that, you could maybe argue that it's slowing, but again, that's excluding 2016 data and 2015 data. But I think most people would argue that based on this graph here, where you're looking over a substantial period of time, the temperature isn't slowing at all. Now, is the percentage of carbon dioxide in the atmosphere, is that a natural phenomena or a man-made phenomena? Well, we can look at that, because by drilling ice cores at the in the caps, polar caps, the ice locks in carbon dioxide that was in the atmosphere thousands, tens of thousands, hundreds of thousands of years ago. And from that we can determine the concentration of the CO2 in the atmosphere. So this shows the data going back. So year 0 here is the present day. And if we go back and note that this is times 10 to the 5, so this is 100,000 years ago, going all the way back to 800,000 years ago. So you can see, yes, there are definitely cyclical changes in the concentration of carbon dioxide in the atmosphere. That is a cyclical event, no one's disagreeing with that. But you can clearly see that once we get to the present day, how it's practically a vertical line on this graph because of the time scale, how rapidly the carbon dioxide concentration has increased in the atmosphere over the past few decades, comparing when you go back over all these various ice ages. So I think looking at this, you could argue that the increase in carbon dioxide isn't a natural event, because we haven't seen a spike like this over the last 800,000 years. So a few slides ago, I showed you plots of sea level rising, global temperatures rising, and the increase of carbon dioxide, the concentration of carbon dioxide in the atmosphere increasing. And I was quite careful in what I said there, that they were all correlated. And because correlation doesn't equal causation, that's true. I don't disagree with that. But the problem is that so correlation doesn't equal causation, but when the evidence starts stacking up, then it does point to a very clear end goal. And just kind of with a bit of silliness, I guess, show that the other way. This shows a graph of the consumption of margarine versus the divorce rate in Maine. And this graph has a 99% correlation. And no one for a second believes that if you want to improve your chances, have a more successful marriage if you lived in the state of Maine, you'd start eating less margarine. This is clearly a freak graph, illustrating that correlation doesn't equal causation. And, if you follow this QR link, there's several more on this site, which are a bit silly and a bit fun. So yeah, completely agree that correlation doesn't equal causation. However, when you take the sum of the parts, when you look at the trend of carbon dioxide, global temperatures and sea rising, they do all correlate. When you add that with the fact that we've understood the greenhouse effect since the 1800s, we can do it in a lab. We show that increasing the carbon dioxide in the atmosphere will create this effect and warm this surface. We can simulate, create simulations, and those tie up with what we observe in practice. And if you do a simple kind of black body radiation calculation, the Earth's surface should have a surface temperature of -19. The fact that we've got this atmosphere and we have carbon dioxide in the atmosphere is keeping the Earth warm and keeping us alive. This life wouldn't survive on Earth if we didn't have this atmosphere. And also we've observed this not just on our own planet, but also on other planets, for example, Venus. So when you start taking all this evidence together, then it does seem very clear to 99% of the scientists that climate change is a result of man-made carbon dioxide.